Okay, so in this lesson, we're going to look at heat exchange. In the last lesson, we looked at how much energy is gained or lost for a given temperature change for an object. Now we're going to look at heat exchange, so how two objects exchange heat with one another. So the principle of heat exchange states that when two objects exchange thermal energy, the amount of energy gained by one object So the amount of energy gained by one object equals the amount of energy lost by the other object. So a lot of times in this, we're going to use an example of water and taking a hot substance and putting in cold water. The hot substance will cool down, giving the energy to the water, which will heat the water up. Now, it's important for right now that we are going to assume that no heat is lost to the surroundings, even though in actuality, thermal energy will be lost to the surroundings. This is a special case of the law of conservation of energy. It can be summed up as heat lost is equal to heat gained. So here we've got some 80 degrees fluid plus 20 degree fluid. They become 50 degree fluid. So this guy lost energy. This guy gained energy. Now let's take a look at a couple of examples. Our first example is pretty simple. A simple ratio can be used to solve this case. 1 liter of 100 degrees Celsius water is mixed with 3 liters of 20 degrees Celsius water. What is the temperature of the final mixture? Well, to do this, so what we've got here is you've got a little bit of 100 degrees Celsius water, and we've got quite a bit of 20 degrees Celsius water. When we mix them, it makes sense that our final temperature will be, well, somewhat closer to 20 degrees Celsius. Because after we're done mixing them, we are going to get 4 liters of water. So we're going to get 4 liters of water here. And how much will all that 4 liters of water be? Well, it's 100 for 1 liter. And then we've got 20 for another liter, and 20 for another liter, and 20 for another liter. What we do is we find the average temperature of all that. And so we get 160 divided by 4 will give us 40 degrees Celsius water. So we add up all of our temperatures for liters divided by 4, we got 40 degrees Celsius water. That's simple. You won't have to do that very often. What we're more looking at is our second example. We've got a kilogram brass block that is 88 degrees Celsius. Placed in 0.44 kilogram of water at 6 degrees Celsius. The final temperature of the water and brass is 20 degrees Celsius. What is the specific heat capacity of the brass block? So we've got a container. And it's important for these to kind of draw them out, get a sense of what's going on. We've got some water here. This water, start labeling what we know, is 0.44 kilograms. It's 6 degrees Celsius. We go to our specific heat capacity because that's going to be important. And water has a specific heat capacity of 4.18 kilojoules per kilogram degrees Celsius. There's our water. Now we've got our brass block right here. This brass block is 1.0 kilogram. It's our brass. And it is currently 88 degrees Celsius. And it has a specific heat capacity of 0.38 kilojoules per kilogram degrees Celsius. Okay. Now let's look at the final temperature of 20 degrees Celsius. So this guy drops in. This hot piece of metal drops in. It cools down to 20 degrees Celsius. So it loses energy because it cools down. So it started at 88 and it cooled to 20. So for the brass, our change in temperature is equal to 20 minus 88, which is minus 68 degrees Celsius. Minus 68 degrees Celsius. Yeah, it dropped to 68 degrees Celsius. Oh, Jiminy Cricket. Oh. Just wait, we'll get there. Oh, you'll laugh too when you see it. Our water. Our change in temperature is equal to 20 minus 6 degrees Celsius. It's equal to 14 degrees Celsius. Right, the temperature of the water went up 14 degrees Celsius. Now, the question's asking what is the specific heat capacity of the brass block? Well, I just went and looked off the sheet because it's on the sheet. But this question is pretending that it's not on the sheet, so we're going to pretend we don't know this. We're going to pretend we don't know this, and we're going to figure this out. Okay, so this is all the information that we know. Okay. Now, here's the important thing. The quantity of heat that the water gained is equal to, so the water gained heat, the quantity of heat, is equal to the quantity of heat that the brass block lost. So the water gained energy, and the amount of energy that the water gained was equal to the amount of energy that the brass block lost. Now with the water, we have all of our information to figure out the quantity of energy it gained. We have its mass, we have its change in temperature, and we have its specific heat capacity. So for water that gained energy, we can do Q equals mc delta T. Q is equal to 0.44 times 4.18 times 14. And now I'm going to have to go get myself a calculator because I can't do that math in my head. And there it is. So 0.44 times 4.18 times 14. It's equal to 25.7488. Kilojoules. That's how much energy the water gained. That's a positive. Now let's look at our brass. Our brass lost energy. Now remember, for the brass, we know the mass. That's good. We know our change in temperature, that's good. We don't know our specific heat capacity. Well, we do, it's on our sheet, but we're trying to figure it out here. And we know how much energy the brass lost. The brass lost this amount of energy. So we can write up our formula. Q equals mc delta T for the brass. Now we know that the brass lost this amount of energy. So the brass lost, so it's negative 25.7488 is equal to 1.0 times C times our delta T is negative 68. Now this is just a simple equation that we can do. We multiply our 1 and our negative 68 together to get negative 25.7488 is equal to negative 68C. Divide both sides by negative 68. And we get C is equal to 0.379 or 0.39 or 38. 0.38. And our units on that's kilojoules per kilogram degrees Celsius. So we figured out our specific heat capacity for brass. This is how you calculate specific heat capacity for an unknown material. And you can identify what material it is. So let's say you have 1 kilogram of an unknown material. You heat it up to 88 degrees Celsius, drop it in 6 degrees Celsius water, measure the temperature of everything at the end. You find out that the temperature at the end was 20 degrees Celsius. You know that that gives you a specific heat capacity of 0.38, which could mean that it is brass, bronze, or copper, because all of those are very close to 0.38. You've just identified what that material is, or at least eliminated a lot of possibilities. All right, so you're going to encounter questions like this. And there's 2 equations that you're going to have to do. It's just Q equals mc delta T. For one of them, you'll know all the information to find out Q. For the other one, you're going to have to find out some information.